for. This is just a continuation of chapter 3, chemical reactions used in titrimetry. So we will still be talking about titration. And then remember, pag sinabing titration, it's volumetric analysis. We are identifying, we are determining the concentration of our sample. We have lots of chemicals in the laboratory and they don't have label for the concentration. They have label for the name of the chemical, but meron doon na mga walang concentration. So for us to know the concentration of these chemicals, we can do titration, or ang tawag talaga natin sa process is standardization. So sa standardization, either we look for the normality or the molarity of the solution. And then the actual procedure in the laboratory is called titration. So sa standardization, either we use a secondary standard or a primary standard. So you have there your sample. This one is the unknown. Unknown yung kanyang concentration. And before we can determine the concentration of this sample, either we use a secondary standard or a primary standard. So meron talaga siyang kapartner na another substance. Okay? Now let's differentiate the two. Ano bang kaibahan ni primary standard? Ay, hindi ko pala siya sinali. Mawag na akong problema. Maghimo ko slide. Dili na ko siya tanan ginasulat. Okay. So, ano bang kaibahan ni secondary and the primary standard? Secondary standards are liquid substances. Okay? Liquid substances. Ito sila. Meaning yan, we have a sample. The sample can be a liquid or a solid. But if you're going to do standardization, you're going to do titration, and then the other substance that you use is a liquid, it is called a secondary standard. Okay? So that will be our titrant here. Pag sinabing titrant, ito yung ina-add using the burette. Hindi ko pala mag-drawing of burette, okay? So this will be placed here, the titrant or our secondary standard. And then our sample is in the flask. We have here the sample plus the indicator. That's the secondary standard. And then we will do the titration until we get the endpoint. And then the volume there used for the titrant will be used in the calculation of the either normality or molarity. Now, if the secondary standard is not available, or actually dapat mas ginagamit talaga si primary standard, this one naman is solid. Okay? Yan yung kaibahan nila. Primary standards are solid substances that are used also during the standardization process. And itong primary standard, ang requirement talaga nito is it should be very pure. Most of the time, it should be 99% pure. So, konti lang class, konti lang yung primary standard natin kasi marami siyang requirement before siya pwedeng gamitin as primary standard. So, anong mangyayari during titration with the primary standard? Mababaliktad siya, class. The primary standard will be placed here in the Erlenmeyer flask together with the indicator. Solid siya. And then, i-dissolve mo lang siya sa water. Siyempre, lagyan mo siya ng water as the solvent. I-dissolve mo pa siya. And then again, sabi ko mababaliktad siya kasi our sample will become the titrant. Okay? So the sample here will become the titrant. Kanina kasi pag secondary standard, automatic since the secondary standard is a liquid, magiging titrant siya. So when you say titrant, it's the substance being added through a burette. Okay? And then ito, magiging baliktad siya. Your sample should be a liquid and it will become a titrant. The primary standard will be here in the Erlenmeyer flask together with the indicator. But the process of titration is the same. We will still add the titrant in the burette. sa Erlenmeyer flask until we reach the endpoint. Okay, until there will be a change in color. And then we will measure how much volume is used here. So ang mini-measure natin class is the volume used sa titrant. We will be using the volume to compute for the normality or the molarity of the sample. Naintindihan ba yon ang sa standardization? I have given you a video of how titration is done in the laboratory. And I think during our activity number 1 last meeting, I have also asked you to watch another video for the titration process. So I hope you can picture out how it is done. And I don't know if you had already your face-to-face laboratory class sa laboratory nito, sa laboratory component nito. I hope you had and you will experience to do titration na kayo mismo. So meron tayong examples here. Kasi pangutanong ko niyo, ma'am, memorize na. Oo, memorize ninyo ni. Memorize ninyo ni kasi tinatanong din ito sa board exam. So we should know what will be the chemicals na gagamitin natin if we want to standardize a certain solution. So just like when you say sodium hydroxide is widely used in the laboratory. It's cheap, it's very common. There are a lot of laboratory procedures that use sodium hydroxide. So it's very important also for us to know the concentration of this substance. And then another thing, sodium hydroxide is hygroscopic. Pag sinabing hygroscopic, these are substances that absorb moisture from the environment. Meron tayong water vapor, di ba? If si sodium hydroxide pellets, you just left it in a table without closure, magliliquify yan siya for after a period of time. Kasi again, kinukuha niyo yung water vapor sa environment and madadagdag yun sa kanya. And that will change the concentration of the sodium hydroxide. So that is the reason why we always do titration with the sodium hydroxide in the laboratory for us to make sure na ano ba talaga ang correct niya na concentration. So we have here primary standard. So 'di ba solid ito, solid. So ito yung ilalagay natin sa Erlenmeyer flask together with the indicator, and sodium hydroxide will become the titrant. Though siya ang sample, pero magiging titrant siya when it comes to the use of the primary standard. So you have to be familiar of what are the available primary standards for our standard solution. So for sodium hydroxide, we have here the KHP. KHP is potassium hydrogen phthalate. Okay, or sometimes this is called potassium acid phthalate. Parehas lang yan sila ha. Or if the KHP is not available, then we can use sulfamic acid. But for sodium hydroxide, the most applicable indicator is the phenolphthalein. Okay, so that's one. Now, we also have a lot of hydrochloric acid in the laboratory. So if we want to standardize it, we want to know the concentration or the normality or molarity of the hydrochloric acid, we may use sodium carbonate as the primary standard. And just like sodium hydroxide, we will use phenolphthalein. Okay, that is also true for silver nitrate. We can also standardize this one using sodium chloride as the primary standard and potassium chromate as the indicator. And then we have EDTA. What do you mean by EDTA? EDTA is ethylene diamine tetraacetate or tetraacetic acid. Parehas lang yan sila. It's a chelating agent. Actually, this is a component of a tube. EDTA tube ng mga medtech, yung pinaglalagyan nila ng blood para hindi mag-clot ang blood. Diba? Pag nag-draw, nag-extract sila ng blood sa atin, nilalagay nila sa EDTA tube. I just don't know what color yung EDTA tube. Diba? Sometimes may red yan sila, may violet. I'm not familiar kung anong color dyan yung EDTA tube nila. Basta meron yan silang EDTA sa loob to chelate. This one is a chelating agent. Okay, to chelate calcium in the blood. Kasi calcium class in our blood is involved in clotting. So meron kasi silang mga procedure sa laboratory na kailangan hindi mag-clot ang dugo para ma-measure nila kung ano man yung i-measure nila doon sa blood. So ang ginagawa, nilalagyan ng chelating agent para i-chelate itong or i-sequester ang calcium para hindi na siya mag-cause ng blood clot. So magagawa na nila yung kanilang procedure. Remember, mabilis mag-clot ang dugo natin. So pag sinabing chelating agent or sequestering agent, para siyang magnet. Okay? Para siyang magnet na mag-form sila ng complex with the metal. So kukunin niya yung metal and then mag-form sila ng complex. That's what chelating agent is. So, yung EDTA, ginagamit natin din ito sa laboratory. And for us to know the concentration of EDTA, we may use calcium carbonate as the primary standard and hydroxynaphthol as the indicator. Now, we have potassium permanganate. Potassium permanganate is a strong oxidizing agent. And we may also do standardization for this using sodium oxalate. And if napansin niyo, wala siyang indicator. Bakit? Kasi potassium permanganate is an indicator itself. Mag-change din siya ng color kapag na-oxidize or na-reduce siya. So hindi mo na need ang indicator dyan. Anyway, we will have a thorough discussion of that when we discuss oxidation and reduction. And then we have iodine. Iodine is used for starch test, but if we want to know the concentration of iodine, we may use arsenic trioxide as the primary standard and starch as the indicator. Sodium methoxide, we have benzoic acid, primary standard, and thymol blue as indicator. Yung ceric sulfate is another oxidizing agent which uses arsenic trioxide also as the primary standard, and orthophenanthrylene as the indicator. Isulod na itong itanan sa atong brain cells. Okay, i-ready ang mga brain cells din ha. Kabalo ko daghan kay mo gina-memorize karong mga panahon na. So, i-free sa ninyo na inyong mga storage capacity din ha, kay mo daghan-daghan kay tag isulod. Okay, tulog og sayo kaon og sakto para dili magsigig kalimot. Next, we have Carl Fisher reagent. Carl Fisher reagent is used for moisture test. We do that in the QC laboratory. Ang mga tambal bitaw nga ilahang ginabuhat inside the laboratory, like powders na ginagawang tablet. Actually, chine-check yan siya ang moisture content. Why? Remember, if maraming moisture, it will be prone sa contamination. Kasi yan ang gusto ng microorganism. If merong water, talagang magta-thrive ang bacteria dyan. So yung mga substances natin, kailangan natin sila i-dry and i-test natin yung moisture content. And that is itong Carl Fisher reagent, one reagent used for moisture content determination of our chemical substances. And then we use sodium tartrate as the primary standard here. Okay? No indicator, just like potassium permanganate. These are examples only of the primary standard and the applicable indicator. Now we have here another one. Konti lang ito. Example, itong hydrochloric acid, ammonium thiocyanate, and sodium thiosulfate. Ito yung mga samples. Now, if in the case na primary standard is not available, then we may use secondary standard. Again, secondary standard class are liquid. Liquid substances sila. The process is the same during titration, but the secondary standard will become the titrant. So if like hydrochloric acid is the sample, we may use the sodium hydroxide as the secondary standard added through a burette, and we can still use the phenolphthalein as the indicator. For ammonium thiocyanate, we have the silver nitrate and the ferric alum as the indicator. For sodium thiosulfate, we have there the iodine as the secondary standard and starch as the indicator. Okay? Examples lang ito. Questions so far? May gusto kayong i-clarify? Tayo cyanide ay na siya ammonium. Tayo cyanide. Tama. Tayo cyanide. Yeah. In secondary standard or pag secondary standard, in here, the sodium hydroxide will become the titrant. Just remember, the titrant is the one being added using a burette. So, siya yung titrant dyan. Pag secondary standard ang gamit natin, ang secondary standard ang magiging titrant. Okay. Sige. Now, let's talk about titer. Minsan you will encounter problem solving involving titer. Ang kailangan nyo lang tandaan, the titer is the normality times the milli equivalent weight. You will be using this one in problem solving that will not give you the normality and the milli equivalent weight of the sample. So, di ba, when we computed for the normality, we use this one as our formula. Okay? Now, there are problems class na hindi niya ibibigay si normality, hindi din ibibigay si milli equivalent weight, pero ibibigay si titer. You have to know that titer is normality times the milli equivalent weight. Okay? And the unit for titer is milligrams per ml. So that is actually the weight in milligrams of our substance equivalent to 1 ml ng standard solution. Yan ang ibig sabihin ng titer. So we will use this one again sa mga problem solving natin in the future. In the future pa kay dili pa nato siya gamiton this afternoon. Okay? That's the titer ha. Ayaw kalimot. Titer is normality times the milli equivalent weight. It is the milligrams or the weight of the substance equivalent to 1 ml of the standard solution. Now, we have here volumetric apparatuses. Ito yung mga ginagamit natin to measure volume. So, number one, to deliver, we may use burette and pipette to deliver. Like we want to transfer the substance, the liquid substance from one container to another. Accurate dapat ang volume na i-transfer ha. So we use burette and pipette. Now to contain, syempre you can store your liquid substances here, and as we store them, we may also see or we may also identify their correct volume. So we may use volumetric flask, a long neck flask with one graduation only. So isang guhit lang siya. If that is for 1,000 ml, para lang talaga siya sa 1,000 ml. So it will contain our liquid substance. And then also our graduated cylinder. So parati natin itong ginagamit in the laboratory when we measure volumes of liquid. So it can contain also our liquid, but at the same time, we can transfer it to another container. But ito lang ha, ito lang yung mga volumetric apparatuses natin. Beaker, Erlenmeyer flask, both of them should not be used in measuring volumes of liquids even though they have graduations. The lines there are not accurate. So, magagalit talaga yung teacher ninyo pag nakita niya kayong nag-measure ng volumes of liquids using either Erlenmeyer flask or the beaker. Okay, now the burette. I believe you are familiar also sa nawong aning burette, no? It's a graduated glass tube. It's a long tube with graduation. And then at the bottom, you will see a stopcock. So this is where like a knob where you can close or open the hole para mag-flow ang liquid inside. Now, for clear solutions, and actually this is the same for all volumetric apparatus, whether you use the pipette, the volumetric flask, or the graduated cylinder. If your solution is clear, again, if your solution is clear, even if it is colored, as long as it is clear, you have to read the volume at lower meniscus. So, di ba yung liquid inside, so if this is the burette, di ba, the liquid inside will be like this, para siyang naka-curve. So the lower part of the curve is called the lower meniscus, and that is the correct reading for the volume of the liquid. Always remember that for clear solutions, whether it is colored or it is not colored, as long as it is clear, lower meniscus yan siya. No, paano kung hindi clear? Turbid solutions. Hindi mo makikita. Hindi siya transparent. Ano tawag dyan? Basta turbid siya. So pag turbid solutions naman, you have to read the volume at higher meniscus. So you have to locate the higher part of the curve, and that will be the correct reading for the turbid substances, turbid liquids. Okay, now we have types of burette. We have the Mohr and the Geisler. The Mohr is used for bases, and this one is cheap kind, cheap. Really siya expensive na burette. This one is economical, pero wala siyang stopcock sa bottom. Instead, may tubing lang siya na connected doon sa separate tip niya. Yung merong stopcock class, which is more accurate but more expensive, is called the Geisler burette. Let me open Google and let me show you the difference between a Mohr pipette and the Geisler. Ay, kagamay man ani niya. How do I make this big? Gamay dyan. So this one, nagida yung pinakadako, no? Ano siya? We have this one. This one is an example of a Mohr burette. This one is for bases, and as you can see, you have a tubing connecting the tip into the body of the burette. Okay, this one again is the Mohr burette. So you may also use this attached knob here to let the liquid flow or to not let the liquid flow. That's the Mohr burette. And then this one, yung pinaka-common, yung commonly makikita niyo sa laboratory class na may stopcock na burette, yun yung Geisler. Okay? So, yan yung Geisler na merong attached na stopcock. So, this one. Okay? So, this one is the stopcock here. I-open or i-close natin ito siya. That's the two types of burette natin. Any questions so far? Or clarifications? Wala ko siguro, no? Wala. Let us continue. Okay. Now, let's talk about types of titration. Titration is not just one procedure or one process. Meron tayong types of titration. We have the so-called direct titration and the residual titration. Now, how do we differentiate the two? Pag sinabing direct titration, you have one titrant used or meron kayong isang volumetric solution. Pag residual titration, you have two titrants. That means you have two volumetric solutions. Ano ibig sabihin yan? Pag direct titration class, if this is your burette and you have your sample here, okay, diretso mo yan siya ilalagay dyan. That is the titrant. And you will directly add the titrant here in your sample. Okay? While you add this, syempre nag-swirl ka. So one titrant or one volumetric solution na ang ginamit dito. Pag residual titration kasi, if this is your sample here, and then this is your burette here, mag-a-add ka first ng isang titrant. Pag na-add mo siya lahat dyan, gagamit ka na naman ng another burette or same burette pero kailangan siyang linisan. And then you will add another titrant. So meron kang dalawang volumetric solution or dalawang titrant here for residual titration. Okay, I hope nakuha ang difference ni direct and ni residual. I-simplify lang na ito para sa kadaghan. Okay, direct isang titrant, pag residual dalawang titrant. Okay, now for residual titration, the first titrant or we call that volumetric solution. The first volumetric solution is added in excess. So, di ba sabi ko kanina, mag-a-add ng first titrant doon sa sample mo and it will be added in excess. And then here comes your second titrant or your second volumetric solution, and that ginagamit ito siya to titrate the excess first titrant na inad mo doon sa iyong sample. So yan yung reason bakit dalawa ang volumetric solution or yung titrant for residual titration. Now, when do we do the residual titration? Number one, syempre, if the direct titration is not practicable, okay? Hindi siya pwede. Wala kang reaction na makukuha. Yan ang ibig sabihin yan. Hindi ka makakakuha ng endpoint. Kahit anong dagdag mo ng titrant, no change in color will occur. Therefore, direct titration is not possible. You have to do a residual titration. And meron kasi talaga tayong compounds that will react slowly with our titrant. So kaya ang sabi ko, wala kang endpoint na makukuha. And other substance will have poor solubility also, especially in water. So slow yung magiging reaction mo. So kailangan dalawang titrant ang gamitin. And another reason why we do residual titration is if our sample is highly volatile. So madali siyang mag-volatilize, and para ma-prevent natin siya from evaporating, we may add an excess titrant and then we will titrate it with another volumetric solution. Okay? Meron bang questions or clarifications about this? The types of titration, direct and the residual. Wala naman na siguro. So let's move on. We have here the so-called blank determination. So pag ma-encounter nyo ito class na you will be asked to do blank determination, it means that you will be doing the whole procedure, the whole titration procedure, but you have to get rid of the sample. You have to omit the sample. So you have here still the titrant. You have here the Erlenmeyer flask, but the Erlenmeyer flask will only contain water, kasi yan naman yung solvent ng most of our sample, plus the indicator. So wala siyang sample pag sinabing blank determination. Ginagawa talaga yan siya to compare results of titration sa merong sample and sa walang sample, baka may variations or may biases along the way. That's when we are asked to do blank determination. Okay, now chemical reactions used in titrimetry. Marami ito sila, 4 ito sila, pero let us start with precipitation this afternoon, and then we will have a thorough, not precipitation, sorry, neutralization. Let's start with neutralization this afternoon, and our discussion will continue pa sa mga succeeding na mga weeks. And then I hope we can finish precipitation sa midterm. And then we will have oxidation reduction and complexation sa finals. Ito yung mga possible chemical reaction involved in the titration process. But before that, we have 4 requirements that have to be met if the reaction is to be used. Number 1, para masabi talaga natin titration is applicable in the standardization of the sample, kailangan the reaction must proceed to completion. Meaning, you can start doing the titration, there will be chemical reaction, and then matatapos mo talaga siya na you will have an endpoint. And that the reaction must proceed in a stoichiometric manner. I don't know if you are familiar with stoichiometry, but stoichiometry class is a branch of science or a branch of chemistry that deals with the measurement of the amount of substances in a chemical reaction. So like na kay chemical reaction, ay, nakita ko sa kuang pen, naraday siya sa akong pikas kamot. Magkanindot. So you have here the reaction A plus B equals C plus D. Pag sinabing stoichiometry, again, this deals with the measurement of the quantity. Kailangan nating malaman gaano karami ang nagamit na chemical A na nag-react with a certain amount also with chemical B, and we can predict how much products will be produced. So kailangan, before we do the titration process, we should know that the reaction between your sample and the titrant should take place in a stoichiometric manner wherein we can really measure both the reactants and the products. And also, we have to make sure that there will be a suitable endpoint detecting device. Most of the time, it will be indicators. So, kagaya ng mga examples ko kanina when we titrate sodium hydroxide with the potassium acid phthalate, our indicator is phenolphthalein. If we don't have a suitable indicator, then useless yung titration process because we cannot see an endpoint. There will be no change in color. But syempre high-tech na tayo ngayon. We also have electrodes used to detect endpoint of the process or the procedure. Now for direct titration, kailangan may rapid, sharp endpoint tayo. Mabilis lang, basig isa ka balde na chemical ang atuang nagamit, wala paghihapon nag-change ang color. Dili na siya practical. So dapat there is a rapid change in color, dapat meron tayong sharp endpoint. We can really identify that there is a change in color. And that signifies end of the titration process. So again, 4 types ito ng chemical reaction involved in the titration process, but we will focus with the neutralization. So sa chemistry, we know that neutralization is the reaction between an acid and a base. So we use neutralization process ng titration if we want to know the concentration of either an acid or a base. So just like this one, we have hydrochloric acid and sodium hydroxide. If they react with each other, we will have a water and a salt as products. Okay? Ito yung sabi ko sa inyo na number 1 question sa board exam namin. Number 1 question talaga ito sa board exam. Area 1, question number 1. That is why I cannot forget this. Ang question doon, what are the products of the reaction between acid and a base? Siyempre, salt and water. So, dili na ko siya makalimtan because that was the time na nakaingon ko sa akong sarili nga naadi unod ako ang puto. Kay before the boards, a night before the board exam, ang akong feeling yun, walay sunod akong nag-study ako, kanang nga feeling. Actually, makarelate mo na pohon pag mag-board exam na mo. Parang feeling ninyo, walay unod din. Walay unod din yung utok na mo ang teacher that time in charge na mag-guide sa amuha. Dito po siya natulog sa amuang gipuyan before the board exam. Ako yung nga, ako mamulay unod akong utok, ma'am. Ano ko sa'yo? Naku kaya akong problema ato nga time. Board exam na ugman niya akong feeling yung gano'n, wala man yung unod akong utok. Kanang naglutang bitaw ka. Lutang lang ng tech. Matuwa naman siya sa kuha na siya, Reza. Pagbasa niyo sa question number 1, makabalo lang ka nga, nanday sulod mo. Tok, ano siya sa kuha. Manang di ko kalimot hantod karon. Pagbasa na ako sa question number 1 ko, ay naday unod akong utok kay kabalo ko sa answer. So, ang answer ato, syempre, water and salt. Pero the rest ng mga questions from question number 2 hangtod sa last, wala na ko yung maalala, class. I don't even know how I answered the questions in the board exam. Ako lang yung nabalaan, yung nagsige kong ampo ato. Question number 1, sige ko kung ampo, Lord, tabangi ko, ano Lord? Ay, dili din ako ni ma-answer, hindi ko ni matabangan. Nga na din ako ang matandaan, nga gihimo na ako. So, muna nga, after the boards, wala na ako nag-istorya. Wala di ko nag-istorya. Ngayon ko sa mong teacher na kulbaan siya sa ako. Kaya nga nang dili daw kumutingog. Di siya kumutingog. Kaya wala ko'y ma-share. Kaya wala ko'y mahinong daw. Nag-istorya sila. Kung sa'yo mong answer, di ba naman na pag after the exam, ang mga estudyante, yung answer din mo sa number 2. Diba? Nag-aana na siya. Ano, wala ko'y malalaw. Sige, question sa number 2. Pamabatian ako sila mag-istorya na ko. Nadi nga na question. Nga na ang nagasulod sa ako ang mind kaya wala dyan ko maalala. So, wala ka nagatingog. Pero ang question number 1, hindi dyan ko makalimot. Kaya dito dyan ko nakabalo di ko sa answer. Naday unod akong nutok. Kung saan mang if-wala din. Naman dyan unod na, oy, tanawan ninyo, pag-take ninyo sa board exam, pagbasa ninyo sa question number 1, kabalo din mo. At yung problema kung pagbasa ninyo sa question number 1, wala din mo kabalo. Wala din mo kabalo sa answer, dihat na maluya. So I hope mag-study dito para dili ta ma-discourage pagbasa na to sa question number 1. I don't like that. Kung sukad nga estudyante ko, dili ko ganahan mag-istorya about sa exam. Kaya dili ko gusto ma-stress bitaw nga, mali ba akong answer sa number 1? Kaya kanang nag-discuss na bitaw sa answer sa number 1. Kani ang answer niya, magpakita na din sila ebidensya nga, mag-give na siyang answer. Ni maluya din ka, kay mali din mong answer sa number 1. I don't like that. So, wala dyan ko nagatingog. Actually, wala. Dili man po dyan good ko makatingog during the exam. Ay ako ginapirmi ang last mabilin sa room. So ako tong estudyante nga maglagot ang proctor. Kay kanang kadugi ba niya human tilukon na. Ano dyan ko mag-exam dugay kay kumahuman. Kung 1 hour and 30 minutes ang time sa exam, mahurot dyan ako na siya ang 1 hour and 30 minutes. Maglagot ang proctor. Kay dili dugay kay kumahuman. Namagod ko yung process mag-exam. Magbasa ko, kung kabalo ko sa answeran ako na siya. Tapos, pag mahumanan ako, like for example, hangtod 100, anhap ako mag-shade. Siyempre, shade ta, diba? Scantron. Sa UIC, Scantron. Sa board exam, Scantron. Sa school, sa doctor, Scantron ta. So, mag-answers ako sa answer sheet for the first round. And then sa second round, mag-shade na ko. So kung sure na ko sa kung answer sa number 1, i-shade na ako sa second round. Pag example sa number 2, dili ko sure sa kung answer, i-blank sana ko na siya. So like katatlo ko class, magbalik o basa sa mga questions. Yeah, before pa dyan ko magpasa, ako pag yung isa-isahon, basig na ako'y nakalimtan. So mo na nga dugay kay kumahuman take sa board exam. So dili to ako ang dili to ako ang naga-answer sa exam kanang dali ko kay mahuman. Mag-answer ko kay kano stress ka sa iya ha kay nagpasa na siya nga naman to. Ma-stress ka magtanaw sa iya ha. Actually na ako'y tandem ana sa exam. Basta exam ang istoryahan, ako'y tandem ana mabilin sa room. Si Eureka. Teacher niyo si Eureka karon, 'di ba? Eureka Granada. O isa batchmate, classmate ba ni Yorks? Dili ko sure kung nag-classmate ni Yorks. Pero ano kanang ano sa tawag na? Batchmate ni Eureka. Doormate mi tapad mi groom. Siguro may uban do. Hangtod karon nag-uban ya pa mi bisag na siya agusan. Nag ano jud ana siya nag-invite ko nga mag-teach siya sa school. Ihatawag sa ko Ate B, akong tawag sa iya Ate Yorks. Duha mi ana like sa board exam since Granada yung apelyido gabilagon ko. So isa jud mi groom ana kay alphabetical man ang room sa board exam. Bilin jud mi ana kada area kaming duha mabilin jud ming duha. Dugay kini mahuman. Okay. Ambot nga nun na. Try kag kapag perfect score sa major subject. Wala man siguro. Wala ata. Dura ko try na. Dili guro sa major. Ang akong maalala sa sa college algebra, sa math lang akong maalala nga nakatry ko ma-perfect ang exam. Yeah. Nag-istorya man ko sa amo ang teacher. Asya Risa, wala man may naghahatag 100 nga grado sa college lagi daw kay sa UIC dili man pareha sa inyo hangat 3, 2.75. Dito sa ilaha kay Roman jud nga grado like 199 ana. Kato lang ako na-try. Kaya siya in-99 lang nato ni Ray sa big. Hangyo mong gupo niya. Muna hindi ko kalimot, in-99 lang nato ni Ray sa kadili daw dawaton sa system pag 100. Pero the rest ng mga major subject tabang kanusta nato mo perfect. Si Eureka siguro na perfect niya na wala ko kabalo. Si Yorks is magna cum laude na siya sa batch. So, diba? Munang ako adyo na siyang ginahila nga pagtudlo na diri ba. Nagatudlo na siya sa Davao to. magna cum laude na si Eureka. Okay. So we have here indicators. Pag sinabing indicators, these are test solutions that will help us determine the endpoint. Okay? Pwede din siyang gamitin to determine the pH because remember, indicators will change color if there is a change in pH. So, ang tawag talaga natin sa kanila, acid-base indicators. Kasi meron din tayong indicators na ginagamit for redox titration. And since we are talking about neutralization here, ano tayo? Acid-base indicators. Ito. So, memorize na muna, ma'am. Yes, memorize na na. Laban lang mga brain cells na to, ha? Okay, these are the most common acid-base indicators that we have. Hindi ko ipapamemorize itong pH range. Hindi na ito kailangan. Pero ang color nila sa acid ug sa base, kailangan. Okay? Pero ani dili man jud ni siya kaayo lisod nga numan. Kasi kung unsa ang color nila sa ilahang name, makita na ninyo diha pod sa ilahang either sa acid and sa base. And always na siya class nga ang partner niya kay yellow. So just like this one, malakite green. Pag sa basic environment siya, like si malakite green, ibutang nimo sa sodium hydroxide, it will be color green. Pero pag ibutang nimo siya sa acid environment, like sa hydrochloric acid, mahimo siya og yellow. So again, always yan siya na kung ano yung color niya sa name, most of the time, yan yung color niya sa base. Tapos automatic, ang color niya sa acid ay yellow. So that is true for malakite green, for bromophenol blue, for, this one is green ha, paki-check na lang. This is bromocrystal green, bromocrystal purple, the bromothymol blue, and the phenol red. Kung ano yung color nila sa pangalan nila, that will be their color sa base, and automatic their color sa acid will be yellow. Para madali ang ato ang life. Now, sa ang exceptions, kaning mga nag-start sa methyl. Methyl yellow, methyl orange, and methyl red. Okay? Kasi baliktad, ang yellow class for the methyl is makikita natin sa base. So just like methyl yellow, yellow siya sa base, methyl orange, yellow pa rin siya sa base, and methyl red, yellow pa rin siya sa base. And then yung acid, yung ibang color nila, pero hindi siya mag-follow sa color ng name nila. Okay, methyl yellow is red in acid, methyl orange is pink, and methyl red is still red sa acid environment. Okay? Questions about this? Laban ang brain cells mag-memorize aniha. Pero wala pa na nahuman ka na pa'y second slide. This one, the cresol red. This is not an exception to the rule. Red ang kanyang color sa base, and then automatic yellow ang sa acid. And then the thymol blue is still the same. Blue ang sa base, yellow ang sa acid na part. Okay? And then idagdag natin class doon sa mga methyl, si phenolphthalein and si thymolphthalein. Okay? Pero ang tandaan natin, ang mga phthalate class sa acid, they are colorless. Pero sa base, yun yung ibang color nila. Si phenolphthalein is red. Actually, ano siya, either pink or slightly purple or red. Si thymolphthalein naman is blue. So, nag-change sila again ng color if there is a change in pH. So, that is why we call them acid-base indicators. And we have to make sure during the titration process na na-add talaga siya sa sample. Kasi wala tayong makukuha na endpoint pag hindi ito na-add. Okay? We are almost done, ha? So, what are our rules in the use of our indicator? Class, during sa titration, we always use 3 drops of indicator to be added sa sample unless otherwise directed. Pag hindi nakasulat na gaano karami na indicator ang idadagdag, it means automatic 3 drops yon. Okay? Now, anong rule natin? Anong indicator ang applicable? Ganito. If you titrate a strong acid with a strong base, either you use methyl orange, methyl red, or phenolphthalein. So, most of the time, our strong acids and strong bases, yung mga inorganic acids and bases yan sila. Which means, yung mga acids and bases na walang carbon in their chemical formula. So like hydrochloric acid, sulfuric acid, nitric acid, di ba wala yan silang carbon? So mga strong acids yan sila. And then sa strong bases also like sodium hydroxide, calcium hydroxide, aluminum hydroxide. Walang carbon. So inorganic base, and yung may OH talaga, strong bases yan sila. So like when you titrate hydrochloric acid with sodium hydroxide, both of them are strong. Either you use methyl orange, methyl red, or phenolphthalein. Okay? But if you titrate a strong acid with a weak base, you have to use methyl red as an indicator for you to really get a sharp endpoint. Okay? So strong acid, ano example nito? Hydrochloric acid pa rin. And like example of a weak base, though this is still inorganic pero weak base siya, we have here the ammonia. Okay? Pag i-titrate mo silang dalawa, you have to use methyl red. Pero pag baliktad, si acid yung weak pero strong si base, like for example, sodium hydroxide here. And anong example ng weak acid? Yung mga organic acid natin, kagaya ng acetic acid found in our vinegar. CH3COH, this is acetic acid. Merong carbon, so organic acid. Weak acid plus strong base, you have to use phenolphthalein. Okay, in the titration process. Now, ma'am, paano weak acid, weak base? Wala tayong indicator and we have never titrated weak acid and weak base. Kahit anong gamitin natin na indicator class, wala tayong makukuha na endpoint. So it is as of now impossible to titrate weak acid with a weak base. Wala tayong available na indicator. So kung gusto mo malaman ang concentration ng weak acid, kailangan strong base ang gamitin mo as the titrant. And you use phenolphthalein for you to have an endpoint. Okay, so for you to be familiar with our strong acids and strong base, MO is methyl orange, MR is methyl red. So nasa ano yan siya sa table. Ito, methyl orange ito. Then we have here the methyl red. Okay, I'll be giving you examples of strong acids and strong bases para madali nyo silang ma-identify. Strong acids again are mostly inorganic acids. No carbon like HCl, that's hydrochloric acid, HNO3, nitric acid, H2SO4, sulfuric acid, and H3PO4 is phosphoric acid. Okay? And then we have the strong bases, they are also inorganic, and yung may mga hydroxides. So like sodium hydroxide, potassium hydroxide, calcium hydroxide, aluminum hydroxide, magnesium hydroxide. Yung mga weak acids and bases natin, most of them are organic. So acetic acid is CH3COOH, and then oxalic acid is COOH. Dalawang COOH ang oxalic acid. So the rest ng mga you learn this one in your organic chemistry na pag acid ganit sa organic chemistry, di ba? Tawag natin sa kanila carboxylic acid acids, and ang ating general formula is RCOOH. And then we have the weak bases. We have the NH3, that's an exception kasi most of them are also organic. So just like the alanine, you have the carbon there, methylamine, and the pyridine. Mga weak bases yan sila. Okay, that's the end of our discussion for chapter 3. Do you have questions, class? Or clarification? Pinahuman na ta og discuss. Na akong tubagon. Sa iluan ninyo, open mo na po.